Hello students, today we're going to look at section 7-8, which is recursive formulas. Now this is going to be based on geometric sequences and arithmetic sequences. Now recursive formulas allow you to find any term in the sequence based on a previous term. Now, if you'll remember when we looked at geometric sequences and finding the nth term and arithmetic sequences and finding the nth term, we wrote what are called explicit formulas. They were all based on the first term. What do I have to do to the first term to get the nth term? Well, recursive formulas take it a little step further, and you have to know the first term, yes, but you don't deal with the first term. You deal with the previous term, and what am I doing to the previous term in order to get my next term? So we're going to look at kind of what it looks like using the sequence 3, 6, 9, and 12. So if I know a sub 1 is 3, and a sub 2 is going to be 6, but how did I get that? I did a sub n minus 1 plus 3. And if a sub 3 is 9, well, how did I get that? I did a sub 2 plus 3. And if I have a sub 4, which would be the fourth term of the sequence, that would be a sub 3 plus 3, which is 12. So what I'm basically doing is taking the previous term and adding my common difference. In this case, d equals 3. That's my common difference. It's an arithmetic sequence. So all I'm doing is taking the previous term. So to find the nth term, I would take a sub n minus 1, which is the term previous to the nth term, plus 3 to get my next term. And there's a few more steps involved in this to write the recursive formula, which I'll show you in just a second. So now that we've looked at what it looks like to be a recursive formula, I'm going to tell you how to write a recursive formula, and that has 3 parts to it. The first part is telling me what the first term is. So I have to write a sub 1 equals 3. First term, that's the first part of the recursive formula. The second part tells me how to find the nth term. So a sub n equals a sub n minus 1 plus 3, because that's what my common difference is. So I just take the previous term, which is n minus 1, and add 3 to it. And then the last part of this is the domain, which is n is greater than or equal to 2. Now notice that n is the number of the term. We already know the first term, so we don't need to find the first term. We're looking for all of the terms after n. After 1, which would be greater than or equal to 2. So all 3 of these parts end up being the formula for recursive. Yeah, it's a lot. There's 3 parts to this thing, but you have to have all of them in order to have the recursive formula. So now let's look at how to write a recursive formula and what the parts of a recursive formula look like for geometric and arithmetic. Now the first part of both recursive formulas is the same. A sub 1 equals whatever the first term is. And the last part is always the same. For the domain, n is always going to be greater than or equal to 2 because we're looking for the second or higher term of the sequence. So the middle part is what kind of is a bit different. So with an arithmetic sequence, it's a sub n equals a sub n minus 1 plus whatever my common difference is. Because remember, with arithmetic, we have a common difference to get the sequence. Now with geometric, a sub n equals r, which is our common ratio for each of the terms in the sequence, times a sub n minus 1. Make sure you know these. I don't think they're on your formula chart, but you're going to need to know them and be able to interpret them. A sub n equals r times a sub n minus 1 for geometric, because remember geometric we multiply. And with arithmetic, a sub n minus 1 plus d would be it, because we add or subtract something to get a sequence in arithmetic. Now let's look at a couple of recursive formulas and figure out what the sequence is. And we're going to come up with the first 5 terms in our sequence. So with example number 1, a sub 1 is negative 2. A sub n equals a sub n minus 1 plus 4. And n is greater than or equal to 2. Well, let's identify a couple of things. Number 1, we know that that's our first term. Okay, so we're going to write that as our first term. Number 2, we know that this is arithmetic because I have plus 4. So we know it's an arithmetic sequence. Okay, so let's write our sequence. The first term is going to be negative 2. And then what am I doing to that? I'm adding 4. So negative 2 plus 4 is 2. And 2 plus 4 is, I don't need a plus sign there. And 2 plus 4 is 6. And 6 plus 4 is 10. And 10 plus 4 is 14. Dot, dot, dot. So we know our first term is negative 2. We're adding 4 to each term to get our sequence. So let's look at example number 2. Example 2 says a sub 1 equals negative 4. And my recursion is a sub n equals 3 over 2 times a sub n minus 1. And my domain is n is greater than or equal to 2. Well, let's identify. We know that this is my first term because it's a sub 1. We know this tells me that it is geometric because I'm multiplying by something. And my common ratio in this case is 3 over 2. So I know that I'm multiplying every term times 3 over 2. So we're going to start with our first term, which is negative 4. And then negative 4 times 3 over 2 is negative 12 over 2, which equals negative 6. And then we take negative 6 and multiply it by 3 over 2. That would be negative 6 times 3 over 2 is negative 18 over 2, which is negative 9. And then our next term is negative 9 times 3 over 2, which is negative 27 over 2, which is negative 13.5, if I did my math correctly. And then the next term, we're not even going there. We're just going to do the first 4 because I don't have a calculator with me. So I would take negative 13.5 and multiply it by 3 over 2, and then we'd keep going. Okay? So this is a way that we take a recursive formula and we figure out what the terms are in our sequence based on the first term that they give us. Now what we need to do is figure out what the recursive formula is from the sequence that I'm given. Okay? So first of all, we have to figure out if it's arithmetic or geometric, and then we'll write the recursive formula based on that. So I'm going to look at example number 3, 6, 24, 96, 30, 84. 6 to 24 is plus 18. We know it's not geometric because we don't plus 18 every time. So 6 times 4 is 24, 24 times 4. So we know it's geometric, and my common ratio, I'm going to put over here, r equals 4. I'm going to multiply everything by 4. Okay? So now that I know that, I can write my recursive formula. I start with my first term. A sub 1 equals 6. Not a big deal, huh? So a sub n equals a sub n minus 1. I wrote that too soon. First, I have to write my common ratio, which is 4 times a sub n minus 1. So I'm multiplying every term by 4 to get the next term. And I know that n is greater than or equal to 2. I'll give you a hint. A sub 1 is always going to be the first term, no deal. N is greater than or equal to 2 this year is always going to be n is greater than or equal to 2 for every one that we do. It's the middle part that's a little bit different, and all I'm doing is changing what my common ratio is for geometric. Now let's look at the next one. Is this geometric or arithmetic? How to get from 4 to 10 is 6. Well, 10 plus 6 is not 25, so it's not that. So I could do 10 over 4, or 25 over 10, or 62.5 over 25, and you probably already figured out that that is 2.5. So my common ratio again is 2.5. I'm multiplying everything by 2.5 to get my next term. So now I'm going to write down my recursive formula, which would be a sub 1 equals 4, because I always have to identify the first term, and then a sub n equals my common ratio, which is 2.5 times a sub n minus 1. And then I always add n is greater than or equal to, what am I doing? N is greater than or equal to 2. That is the way we take a sequence and then write our recursive formula for it. So the last part of this whole topic is the most difficult for me because I'm having to think a whole lot in this one. I'm taking an explicit formula and writing it in recursive formula mode, or I'm taking a recursive formula and putting it in explicit. Lots of thinking on lots of stuff from what we've been doing over the last couple of days. So let's look at the example. Write a recursive formula for a sub n equals 6n plus 3. Okay, that's the explicit formula, and that's what we learned when we found the nth term for arithmetic sequences. So I know it's arithmetic, and I got to find my first term. Well, to find my first term, I would say n is 1. So 6 times 1 is 6 plus 3 is 9. So I know that a sub 1 equals 9. And now I've got to figure out what is my common difference. Well, the common difference is always multiplied by n. Okay? Common difference is always what's multiplied to the coefficient of n. So my common difference in this is 6. So now I'm going to write the rest of the recursive formula. A sub n equals a sub n minus 1 plus 6, because that's my common difference. That is d. That looks like an a, so let's change that and make it a d. That is my common difference, is the coefficient of n. And now n is greater than or equal to 2 because it's always the same in every one. So I pulled out some information from this explicit formula, plugged it back into recursive. So now let's take a recursive formula and make it explicit. So we got to pull out some data from here. We know that my first term is 120. Hallelujah, they told me that. I don't even have to figure it out. They told me that my first term is 120. I can tell that this is a geometric sequence because it's multiplying something. So that's geometric, and that's r. R is 0.8. Okay? So you remember, if you need to flip back in your notes to make sure you remember that the formula to find the nth term is a sub n equals a times r to the n minus 1. Well, a sub 1 times r to the n minus 1. So a sub 1 is 120. R is 0.8 to the n minus 1 power. I'm sorry, that's kind of mixed in with that. So the formula that I would need in this case, the explicit formula for this recursive model is a sub n equals 120, which is my first term, times 0.8, which is my common ratio, to the n minus 1 power. And there we have, going back and forth between recursive and explicit. And here are your two practice problems for this video. The first one says to find the first 5 terms of this sequence that you're given. You're given a recursive model, a sub 1 equals negative 5, and a sub n equals 4 times quantity of a sub n minus 1, and n is greater than or equal to 2. Give me the first 5 terms in that sequence. The second one says write a recursive formula for this sequence, 1, 6, 11, 16. So you got to figure out whether it's arithmetic or geometric, and then find the recursive formula for this sequence. Take a picture of those two practice problems and submit it using the turn in button in Edmodo.